Hi everyone, this is Goutham Selvakumar doing my software presentation on deep learning with PyTorch, a practical introduction. So this presentation is basically about a powerful library known as PyTorch and how it's implemented on various examples and how to set up PyTorch. So this is for DSC 672 Data Science Capstone project. So let's go ahead in the upcoming slides with the PyTorch and its uses. So before I go with the complicated examples, let me explain what PyTorch is. So PyTorch is basically a popular open source machine learning library developed by Facebook's AI research lab FAIR. It's designed for both researchers and developers in order to easily build and train the neural networks. So one of PyTorch feature is its flexibility, allowing for easy and fast prototyping of deep learning models. Python actually supports symbolic programming, enabling the optimization of computational graphs for more efficient execution and the ability to run models in environments outside of Python. It's also known for its supporting imperative programming, which makes it more intuitive and easier to debug by allowing developers to write programs that execute operations as they are called. So one of the core features of PyTorch is its use of dynamic computation graphs. As I mentioned before, this graph is built on the fly as operations are performed. This offers a significant advantage in terms of flexibility as it allows for changes to be made for the network architecture at runtime. PyTorch is also used in the tensor library, enabling for multidimensional arrays to be manipulated efficiently. So these tensors are similar to NumPy arrays but have the added advantage of GPU acceleration. So the use of GPU is that during the number of epochs that we run day by day, GPU is actually useful in processing the steps faster and reduces the training time. So PyTorch intuitive interface and flexibility have led to its widespread adaptation across academia for research purposes and industry for developing commercial applications. Its ability to facilitate rapid development and testing of models without sacrificing performance has made it a preferred tool among researchers and developers alike. So, with the definitions of PyTorch, how it is actually compared with the other frameworks in the real world. So, as I mentioned before, PyTorch is a powerful library actually used by a number of researchers in order to fast-pace their research process. So, we will compare it with the TensorFlow, which is developed by Google. So, TensorFlow is another leading deep learning framework that offers both flexibility and scalability, same as PyTorch. So, this TensorFlow actually supports computational graphs, which means the architecture of the models must be defined and compiled before it can be run. There is also TensorFlow 2.0 introduced in order to make it more dynamic and similar to PyTorch in terms of development flexibility. So the another one is Keras. So this is a neural network library which was designed with the aim of enabling fast experimentation. So this TensorFlow and PyTorch making it user friendly but sometimes less flexible for complex model designs. The tf.keras is the TensorFlow, which makes it part of the core library and combining Keras ease of use with TensorFlow's powerful features. So PyTorch, another useful thing is its a user-friendly interface. The API is very straightforward and reduces the learning curve for Python users and simplifies the transition from concept to implementation. So the reason why I chose PyTorch for this tutorial for my software presentation is because of its syntax and dynamic nature that facilitates quick model prototyping. Researchers can easily test new ideas and modify their models on the go, which is very crucial. And PyTorch is very useful for its simplicity and flexibility, which makes it on the go tool. So before going with the example, I will tell you how to set up PyTorch. So setting up PyTorch is very easy in comparison to the other libraries. So mm, PyTorch is very much essential if a system has a GPU in order to work with it, because as I aforementioned, GPU reduces the training speed, and also a GPU is very much useful in comparison with the CPU that I mentioned below in my code. My system recognized only the CPU, so I'm going with the CPU for this tutorial. So uh, from the below code, we can see the torch.device CUDA if CUDA underscore available else CPU. So this code actually checks if our system supports GPU. If the GPU is not present, it will automatically go with the CPU. I'm randomly testing with values 3 comma 3 for the tensor, and this is just a simple operation to demonstrate you're working with tensors. So this is how the approach for setting up the PyTorch is done. So next up is the autograde automatic differentiation, the first example of using the PyTorch. So the autograd is at the core of neural network training. It records the graph of all the operations performed on tensors that have their requires grad attribute set to true when computations are completed. This process is very crucial for the training of neural networks, where gradients represents the changes needed in the model's parameters in order to minimize the loss function. So below from the code we can see I imported the torch, which is the package that is needed in order to define the PyTorch inside the code. So first step is creating tensors. So we will define with two tensors that is represented by x and y respectively, and second step is defining the operation. So I will explain in the upcoming thing. So there is a basic operation where we do a partial derivative on the respective tensors of x and y. The third one is computing the gradient, which is the dot backward of. um, so this code will calculate the gradient of z with respect to x and y. So the partial derivative that I aforementioned, how it is actually useful is uh, in the step 2 if you see x equal to x into y plus x 2x. So basically we will do partial derivative on the first tensor, that is the x. So the z by the x equal to, so the x will be cancelled, and when we input 1 into the x value, we will be getting 4.0 as the tensor output. So the same step follows for the tensor y with doing the partial derivative for the y. So we will be including the 2 into this place, and we will be getting 1.0. So this simple example illustrates the power of PyTorch's autograd system in tracking operations and automatically computing gradients. By abstracting away the complexity of gradient computation, AutoGrad the allows us as the users and the also the researchers in order to focus more on the architecture and the overall logic of their models. So this is another example of using the uh, PyTorch in a more complicated method, convolutional neural networks. So PyTorch is basically very much essential for deep learning models. So this simple CNN model has been successfully defined and instantiated, which showcases the convolutional neural network architecture in PyTorch. So the first convolutional layer takes an input with three channels. This 32 cross 32 RGB image, which produces 6 output channels using a 5 cross 5 kernel. The second convolutional layer further processes the data with 6 input channels and increases the depth to 16 output channels, again using a 5 cross 5 kernel. A max pooling layer also is defined with a 2 cross 2 kernel and a stride of 2, which is applied after each convolutional layer. After the convolutional and pooling layers, the data is flattened and passed through three fully connected layers. That is the fully connected of one, FC2 and FC3. which outputs 10 classes in the FC3. So from the below output, we could see uh, that the first convolution layer takes an input with three channels and applies six filters of size 5 cross 5. And the convolution layer 2, which is the which contains the polling layer, um, features six maps as input and applies 16 filters of size 5 cross 5. The max pooling layer is used after each convolutional layer in order to reduce the spatial dimensions. So by doing this, the network becomes more focused on most prominent features and becomes more efficient by reducing the number of parameters. So the data flow through the network starts with the input image passing through the convolutional one layer, followed by the pool layer, then through the contour, which is the convolution layer 2, followed by another uh, max pool layer. The output is then flattened and passed sequentially through FC1, FC2, and finally FC3, which is the fully connected convolutional layers. So this overall code explains us uh, the convolutionally connected layer acts as a classifier on top of these features. Despite its simplicity, this model can capture the hierarchical structure of visual data and is capable of achieving remarkable performance on tasks like image classification, especially with the right training regime and hyperparameter tuning. So the last example is implementing the PyTorch for image classification using a default dataset Cipher10. So Cipher10 dataset actually contains around 60,000 32 cross 32 color images in 10 classes with 6,000 images per classes. It's widely used for benchmarking image classification models and this PyTorch Torch mission makes it easier to load this dataset in a ready to use format. So we will go with the coding. From this code we can see that the data is downloaded and pre-processed and it is ready to be used. So uh, it actually loads the Cipher 10 dataset for both training and testing and applying the defined transformations. So basically the download equal to true tells us that the download is completed without any fail, and we are ready to go on the further steps with the training and evaluation of the Cipher 10 dataset. So this is the output that I got by running the accuracy of the model on the 10,000 test images. So I actually have a good system that makes it easier to run this, but as I aforementioned, if you're able to test epochs on a very powerful computer that has a GPU which is very more powerful, then the processing speed will be very much quicker and the training time will be much more reduced. So from the output we can see uh, that the nn dot cross entropy loss of function is standard for classification task. So the loss function combines the softmax and the in one single class, making it suitable for predicting a single class out of n classes. So the optimizer that I used is basically the stochastic gradient descent, which sets up the model parameters with the use of learning rate, that is 0.001 and 0.9 as the momentum. So the training process actually runs for 10 epochs. So the first thing in the training is zero gradients, which is accumulated to existing gradients from the previous forward passes. Then I include the compute loss and the backward pass. So after training, the model's performance is evaluated on a separate test dataset. So for calculating the accuracy, the number of correct prediction is summed and then divided by the total number of images in order to calculate the overall accuracy of the model. So from the output, we can see the loss values are decreasing over time, which is actually a good sign. It indicates that the model is learning from the training date. So HTTP basically takes reduces the loss function step by step in order to indicate that a model is learning. And also epoch represents a full pass through the entire training data set. The training process reports loss every 2000 mini batches. Since Cipher 10 has 50,000 training images and assuming a batch size of 4, Each epoch consists of 12,500 batches. Reporting every 2000 mini batches means you are getting updates approximately every 8,000 images, which is a good sign. So we can see the most significant drop in loss occurs in the early stages of training. This is typically for neural network training as a model quickly learns from the data initially. The loss continues to decrease with each epoch, indicating consistent learning. However, we can see the rate of decrease slows down, assuming that the model is approaching its limit in learning from the training data. So this is how the PyTorch is implemented in the convolutional neural network in the autograde differentiation and the Cipher 10 dataset. So in order to conclude my software presentation, I will just go through the glimpse of what I explained before. So setting up the PyTorch is very easier, and if you are fast to use this library, the PyTorch, GPU is very much essential, and in my opinion, GPU is very much recommended if you are doing anything related to neural networks. So uh, we actually went through the AutoGrad system, which tells us the neural network training, enabling easy computation of gradients with minimal code. And we built a CNN with PyTorch, explaining the roles of convolutional layers, pooling layers, and the fully connected layers in extracting features and making predictions. We then went with the Cipher 10 dataset, where we outlined the steps which trains the model on the Cipher 10 dataset, including the loss function and optimizer, setting up a training and evaluating the model's performance on the test data. So before I conclude my software presentation on this, I want to let you all know that PyTorch is very powerful library, and it is actually used in the real world companies too for image classification, for the computer vision, the neural network layers. So using of PyTorch is very much essential as we dive deep into advanced topics. PyTorch is actually very capable of handling libraries that offers vast resources for learners and experts alike. Uh, so with this, I conclude my software presentation, and thank you guys for your time and consideration. Thank you.